Welcome to the Slop Farm. Enjoy the video.
You start by preparing code and data. Install Python and NumPy, create a virtual environment, and load a small dataset. Next, you structure your tensors with consistent shapes and split into train and validation sets. Once done, define the model blueprint, number of layers, units, and activation functions. Initialize weights with small random values and biases to zeros. Make sure to write a forward pass function that computes layer outputs step by step, so you can test arithmetic immediately. Now you implement the core loop that makes learning happen. You write a forward pass that saves intermediate activations and linear inputs for each layer. Then implement the loss function and derive gradients via backpropagation. Compute weight and bias gradients using the stored values. Once gradients are correct, apply an optimizer like SGD or Atom and update parameters. Include a learning rate and optional decay. Make sure to monitor loss and accuracy each epoch and add gradient clipping if values explode. Finish by evaluating the trained network on your validation set and saving the best performing weights. You should add checkpoints and simple metrics logging so you can replay experiments. If performance is poor, try reducing learning rate, adjusting batch size, or adding L2/dropout regularization. If things go wrong, inspect tensor shapes, gradient magnitudes, and numerical stability. Print intermediate activations to find NA-NS or exploding values. Finally, run a few unit tests for forward and backward passes to ensure correctness.
Thanks for watching. Consider subscribing if we helped you today.